Everyone, I'm Yogadharani, working as Assistant Professor in Department of Computer Science and Engineering at SNS College of Technology. Today, I'm going to discuss you what is hyperparameter tuning from the unit of convolutional neural network and the subject of deep learning and applications. Before we get into the topic, we just recall what is a feed forward neural network. It acts similar to the RBM. RBM stands for restricted Boltzmann machine, and neural network is nothing but neurons are there, and main working of a neuron is to extract or what are the inputs, collect the inputs and process to the hidden layer, and then it passes to the output layer. And deep networks are which is similar to the neural network, but it has fewer more number of hidden layers are there. To improve its performance, more hidden layers are there compared to the RBM. And regularization in deep learning is nothing but L1, L2 are familiarly used in deep learning, and then model exploration. And here model exploration, it sets the foundation by reminding you that model performance depends on how well parameters are tuned here. So before tuning, we must understand model behavior and training process. In real world example, before tuning a car engine, we must understand how it currently performs. So in this objective slide, it highly highlights the importance of hyperparameter tuning, that is faster training, which is nothing but optimization and stability. Wait a minute. Here, a stable learning, which means it is avoid oscillations, and then better generalization, and then effective use of resources. Here, the concept of hyperparameter controls learning speed and model behavior. From this side, here real world example is in mobile apps, optimizing setting ensures a smooth performance without overheating. Here, understanding the scenario, here hyperparameter tuning helps maximize accuracy and prevent overfitting, and then ensure the stable convergence. Here, the concept is different parameter settings. It leads to different model performances. And here for a better understanding, in online shopping recommendations, tuning improves product suggestions accuracy. Here an empathy part, here what is the pain point of the problem faced is here slow training and unstable the gradients, then overfitting or underfitting. Here, the hyperparameter tuning, which is selecting the best values for parameters like learning rate, batch size, what is the weight bias, likewise. For this concept, for a better understanding, in quicking, while quicking, we wrongly inheritance quantity leads to poor taste. Likewise, this working here, and then. Next, a defined part here, hyperparameter tuning the finding optimal settings like learning rate, batch size, and then random forest. In ideate part, here here two types of methods are used while hyperparameter tuning, and the main one is grid search and then is random search. Here, grid search is nothing but we select all the possible models in one. Here, the data are placed or fixed in a grid format, that is rows and column format. While in random search, which is similar to grid search, but the only one difference is we are not evaluate all the possible rows and columns here, rather than we pick random data sets and solve that and find the best configuration. So here the main disadvantages in random searches, there is a possibility to miss the best solution because we are not evaluate each and every rows and columns. While in grid search, the main disadvantage is it takes long time to evaluate all the coordinates in rows and columns. And then here key parameters are used eta, gamma and there. And the efficient solution is automatic tuning, that is find optimal running rate, improve convergence and reduce overfitting. Here automation improves efficiency and performance. That is while using cameras, there is a automated cameras, right? So it adjusts settings automatically for better picture quality. So this hyperparameter tuning shows the images of adjusting parameters before training. Here hyperparameters are not learned but set manually and automatically. Here setting exam strategy before writing, time allocating per selections. So in this example, it shows the lower momentum rate and this shows the larger momentum because there is a lack of training during the training period. And this is the hyperparameter. They are starting in hyperparameter. This is a high momentum here. Then here hyperparameter tuning, it shows the poor tuning and it leads to overfitting and it has the large momentum. Likewise, it maximizes the accuracy and it prevents overfitting. It is stabilized training and speed up convergence. Here proper tuning leads to optimal learning. Example in while sports training, proper coaching improves performance and consistency. Here, this includes the improving accuracy, controlling model behavior, and reliability. Likewise, here it shows how the model behaves. And then purposes are already known about that: improves efficiency, prevent overfitting. It gives the best accuracy and generalization. And applications of hyperparameter tuning is it mainly used in image recognition, NLP, that is a natural language processing, and speech systems. Here it is essential for all AI systems. That is while we're using the 5G phones or 4G phones, face unlock in phones, voice assistants like Alexa, Siri, and then chatbots are widely used nowadays. Yeah, this was the knowledge map of this hyperparameter tuning. We saw about what are the purposes of hyperparameter tuning and see with each slide with the real world examples and advantages like it prevents overfitting, accuracy, it tells the what does the model behaves likewise. And here tools used are replicability, that is Python, PyTorch, we can code this one. And then key elements are hyperparameters and matrices are accuracy, FN score, then ROC curves likewise. And we saw about how it works. And here the mainly algorithms are grid search and random search. And here we use Keras tuners to solve the code in this one. This is the small activity in a classroom session. So thank you. Here I give the overall conclusion of hyperparameter tuning is it's a crucial step in deep learning that focuses on selecting the optimal set of parameters to improve model performances. Since hyperparameters directly influence how a model learns, improve choices can lead to slow convergence, instability, overfitting, or underfitting. By applying techniques like grid search, random search, and Bayesian optimization, we can systematically identify the best configuration for our model. And this results improved accuracy and generalization, faster and more stable training process, and efficient utilizing of computational resources. Thus, hyperparameter tuning ensures that the model performs effectively not only on the training data, but also on unseen real-world data. Hyperparameter tuning refines the learning process, transforming a basic model into an efficient and high-performing system. Thank you. I catch you in another video. Thank you, everyone.